Hello, this is Miss McCauley, and this is How to Simplify Expressions Part 1. In this video, a former teacher, Mrs. Bino, will be teaching you how to simplify expressions.
Alright, so today we're going to be talking about simplifying expressions. Now, we've already learned about how to write expressions in the real world. And unfortunately, sometimes in the real world, expressions aren't maybe in the simplest form that they need to be in. So it's really important that we know how to make things easier by simplifying expressions, because everybody wants things to be easier, right? So first we're going to do a quick review just of the parts of an expression. Then we're going to get into actually simplifying expressions, what that means. We're going to be representing and simplifying these expressions with our algebra blocks, which you learned about in the investigation. And then eventually at the very end, we'll be talking about how to apply those expressions and simplifying to real life situations so that you can really use this math in your everyday life. Make sure as we're going through that you're taking all the notes that you need to and you're really, really listening to the video. It's very, very important. This is the step where you are learning what to do. So make sure you're really taking your time to do that. Okay? If you're confused, make sure that you're asking questions, asking your teacher for help. Okay? But the first step is to really make sure you're paying attention. Okay, so we should have our simplifying expression notes loaded into GoodNotes. Let's go ahead and turn to our first page here. So the first thing we need to discuss are the different parts of an expression and what we call them with math vocabulary. We all know that learning math can sometimes be like speaking another language. So it's really important that when your teacher uses these words, you understand what they mean and you are able to start using these words when you're talking about math expressions. So right here we've got the expression 4x plus 12. Okay? And the first thing that we're going to be talking about here is this 12 off to the side. This 12 off to the side here is what we call a constant. And so we're going to write that in this box right above 12. Constant. Make sure you're spelling this correctly. Okay. A constant is a term without a variable. Okay, so once again, a constant is a term that doesn't have a variable. So you can see the 12 has no letter attached to it, so that will be considered a constant. Now our other terms here, the 4x and the x, both have a variable attached, so we would not call those constants. The next thing we're going to talk about is something called like terms, okay? So you can see here that 4x and x both have an x in them. And when we represent this with the algebra blocks, you'll see that they're both represented with the same kind of block, the x block. So we would say that 4x and x are like terms. Okay, if you're thinking about the algebra blocks, it means they're represented with the same kinds of blocks. Okay, so like terms contain the same variables, to the same power. And basically what that means is that x and x squared, or x to the second power, would not be considered like terms because they're raised to a different power. So once again, x and x squared, that's x squared, are not like terms. Okay. The next thing that we're going to talk about is how many terms there are in this expression. And terms are any part of the algebraic expression. And you can see here that we've got 4x, x, and 12. Each one of those is considered a term. Let's write that down here. Get my shapes on still. So remember, a term is any part of the expression. And in this example, we could say that there are a total of 3 terms: 4x, x, and 12. Okay, the last variable we need to discuss is something called coefficients. Go ahead and say that to yourself out loud. Coefficients. One more time. Coefficients. It's a weird sounding word. Here's how it's spelled. I know, it's a long word, right? Make sure you take your time and get it written down correctly. Okay? So coefficients are when you have a variable, if the number that's attached to the variable is considered the coefficient. Okay? So in this case here, if we look at 4x, okay, we can see that the coefficient is 4. That's the whole number attached to the variable here. Okay? Now, this x over here is a little sneakier because there is no number in front of it. But in math, we can assume that if there's nothing written before it, it's like there's an invisible 1 right there. Okay? So once again, if you just have the variable x, the coefficient is 1. Okay? So be careful of that. There's always a coefficient there, even if it isn't written. Okay? That's when you can assume that it is 1. And let's write down our definition for coefficient. Okay? Before we move on. So coefficients are the numbers attached to the variables. Okay? Okay, so that concludes our first set of notes on the vocabulary terms of an expression. We've talked about like terms, which are terms that contain the same variables to the same power. We've talked about what a constant is. A constant, remember, is a term that doesn't have a variable. So in other words, just a regular old number. A term is any part of the expression. So remember, in our expression 4x plus 12, we've got a total of 3 terms. And then last but not least here, the coefficients here are 4 and 1. Okay, let's put our knowledge into action now. Go ahead and swipe the page, and we've got our first expression here to try. 6n minus 7n minus 4 plus n. Okay, and what we're going to be doing here is labeling the terms, the like terms, the coefficients, and the constants. Let's start with the terms. We can say the terms are 6n, remember these are the parts of the expression, negative 7n, yes, that's right. Since there's a subtraction sign here, we have to group that with our 7n. Okay, so that's called as negative 7n. Okay, negative 4, once again, because the subtraction sign is in front of it. And our last term is n. Okay, so again, our terms are 6n, negative 7n, negative 4, and n, which means we have a total of 4 terms. Alright, the next thing we're going to take a look at is the like terms. Remember, these are terms that have the same variable to the same power. Here I've got 6n, and so I'm going to look for any other n's that I see that aren't to a different power. I've got negative 7n and positive n. So I can say my like terms here are 6n, negative 7n, and n. Okay, all of those would be considered like terms. Now my other term here is negative 4. If I had other whole numbers, I would say that those are like terms to -4, okay? But in this case, we just don't have any. Next thing is our coefficients, okay? Well, 6 is attached to n, so that's going to be my first coefficient. -7 is also attached to an n. Okay, we don't do this for whole numbers, so skip -4. And then last but not least, that n. What is the coefficient if there's no number written? You got it, it's 1. Okay, so our coefficients are 6, -7, and 1. Okay, last but not least, our constants. Remember, our constants are any terms that don't have a variable with it. In this case, our constant is -4. We just have 1 in this case. Sometimes there's more, sometimes there's less. All right, let's try another one. Now we've got the expression 9y minus 4 minus 11y plus 7. Again, let's start with our terms. So pull out each part of the expression. We've got positive 9y, -4, -11y, and positive 7. In this case, let's look now at our like terms. Remember, like terms have the same variable to the same power. I see 9y and -11y are both y's. So I can list those as like terms, 9y and -11y. Now the tricky thing here is we actually have another set of like terms. Do you see them? That's right, it's -4 and 7. Whole numbers are also considered to be like terms, so we can list another set of like terms to be -4 and 7. Okay, anything that doesn't have a variable attached, you would group together. Okay, next thing we're talking about is the coefficients. Remember, coefficients are numbers attached to variables. So in 9y, I can write down that one coefficient is 9, and in -11y, my other coefficient is -11. Next, I need to list my constants. Remember, constants are numbers that do not have a variable attached. In this expression, we have 2. We've got -4 and positive 7. And that's how we've organized that expression.
Please answer this question and show your answer to your teacher. You may also answer it in the note check if you prefer.